This video serves as an introduction to the unit circle. There's two things that I want to focus on. The first would be the quadrantal angles, and second would be how to fill out the first quadrant of the unit circle. Before I dive too much into that though, I'd just like to review a few concepts that you would have already picked up in your Task 1 and Task 2 assignments. So if you haven't done that yet, go back, complete Task 1 and Task 2, that's 10.2, Day 1 and Day 2, and then come back to this video. Okay, so the first thing that I'd like to review is that in a unit circle, it's essentially on a coordinate plane, where this is the x-axis, this is the y-axis, and each part of the unit circle is in different quadrants. From here to here, from my positive x-axis to my positive y-axis, all of this area is in quadrant 1. From here to here, this whole section is in quadrant 2. This section right here would be quadrant 3. And all of this section right here is quadrant 4. The quadrantal angles are the angles that separate each quadrant. And this ends up being the positive and negative x-axis as well as the positive and negative y-axis. We're going to start right here at 0, we'll do degrees first. Starting at 0 degrees, a full rotation of a circle would be 360. Because a circle has 360 degrees. Now, to get from this angle to this angle, notice how a right angle would have to be drawn. Right? So that's a 90-degree angle going from 0 to here. Going from 0, because we're always starting in standard position, from 0 to here, that's a semicircle or half of 360. Or another way to think of it is that's a straight line. And a straight line is 180 degrees. Then to get from here to here, that's another 90 degrees. So we're going to add 90 to 180 to get 270. And notice how if I would add 90 to 270, that would give me 360. So I've completed a full rotation of the unit circle. Quadrantal angles could be measured in degrees, but that's not the only way we can measure them. We also would use radians. So a full rotation of a circle in radians would be from 0 to 2 pi. We're going to use the same mentality of if from 0 to here is a semicircle, so half, 0 to here would be half of 2 pi. And half of 2 pi is 1 pi. Or just pi. 90 is the halfway between point of 0 and 180. So the halfway between point for 0 and 1 is 1/2. So this is going to be 1/2 pi, or we would write that as pi over 2. Once again, cutting them in half, halfway between 1 pi and 2 pi would be 1.5 pi. But we're going to write that as an improper fraction, so that's actually going to be 3 pi over 2. So now you know how to write the quadrantal angles in degrees and in radians, but we also need to know how to write the coordinates. Coordinates are in the form x, comma, y. It's called a unit circle because the radius is 1 unit. So this would have a length of 1, this would have a length of 1, this would have a length of 1, this would, any radii. And remember from geometry days, a radius connects the center of the circle to a point on the circle. So that's why I said each of these lines would be a radius. if I'm just looking at the quadrantal angles, so going from the center to this point right here at 0 degrees, I've moved right 1 unit from the center, but I did not move up or down. So the coordinate would be 1, 0, because 1 is along the x-axis. To get to this quadrantal angle of 90 degrees or pi over 2, that's up 1 from the center. So the coordinate would be 0, 1. Now here at the 180 degrees or pi, that's left 1 unit from the center. Remember that moving left is a negative movement and it is an x value. So -1, 0. And then lastly, the 270 is 1 unit down, so that would be 0, -1. Because once again, moving down is a negative movement, and that affected the y value. That's everything you need to know about quadrantal angles, so degrees, radians, and coordinates. We also are going to write the degrees, radians, and coordinates for quadrant 1. So I'd like you to flip it to the back of the sheet and write what I have to say about the special right triangles. I would like for you to pause the video and copy this down exactly how I have it. When you are ready, hit play. We're now going to write the special right triangles for a unit circle. In your introduction to Chapter 10 notes, you reviewed the rules for the special right triangles, and you also solved for missing lengths using special right triangles or sine, cosine, and tangent of those special angles. In a unit circle, and I'm going to jump back here real quick, we can create the special right triangles in the unit circle. For example, in order to draw a triangle, all I have to do is draw the point that's connected to the circle and drop it to the x-axis, thus creating a 90-degree angle. So what I've just created here is a right triangle with a theta or reference angle of 30 degrees. So that would make this a 30, 60, 90 right triangle. I'm going to come back to this idea a little later. For now, in a 30, 60, 90 of a unit circle, because the radius is always 1, I know that the hypotenuse is always 1. I'm essentially saying that the hypotenuse is the radius. If I look back here in my 30, 60, 90, the hypotenuse was the radius of the circle, so I knew that this would be 1. Given one length, we can find all of the missing lengths. If the hypotenuse is 1, I can solve for the missing lengths. So I know, looking at the rules, the hypotenuse is double whatever the shortest side is. So if that's true, if the hypotenuse is 1, it'll be double 1/2. So 1/2 is the shortest length, which means now I can find the longest length because that's going to be 1/2 times √3. Or I could rewrite that as √3/2. For the 45, 45, 90, that's not as easy to solve for because I see that the hypotenuse is 1. But typically the hypotenuse is the leg times the square root of 2. So I'm going to have to write an equation here. 1, the hypotenuse, is equal to the shortest leg, or excuse me, just the leg because they're both congruent, times √2. And we're just going to solve for x. I'm going to divide by √2 on each side, and that gives me 1 over the square root of 2. This is not an acceptable answer. We're going to have to rationalize, which means I get √2/2. plugging that in for my legs. Because they're congruent, I just write them both as root 2 over 2. Now we're going to take a look back at the front page. We already created a 30, 60, 90 triangle. I know that the hypotenuse is 1. The shortest length is 1/2. And the longest leg is root 3 over 2. I got that just by using my special right triangle for a unit circle. We're going to use this right triangle in order to write the coordinates of the 30-degree angle. So the coordinates are going to be x comma y. I'm going to scooch this over to make it a little easier. The coordinates are x comma y. So that's going to be root 3 over 2 comma 1/2. In your task 2 for this week, you should have also learned that 30 degrees is equivalent to pi over 6. Let's take a look at our next special triangle. So now this right here, we're going to create a 45, 45, 90 triangle. And I know in a 45, 45, 90, if the hypotenuse is 1, the legs are both root 2 over 2. So if I want to write the coordinates of a 45-degree angle, which is also equivalent to pi over 4, that would be root 2 over 2, comma, root 2 over 2. Because that was the x and y value. Okay? Last special triangle. We're going to connect our point on the circle to the x-axis, creating a 60-degree reference angle. So that means I have a 30, 60, 90. We're still going to use the special triangle that we have on the back, which is 30, 60, 90. I know that the shortest leg is opposite to the 30-degree angle. So this right here along the x-axis will be 1/2 because that's my shorter leg right here. The y value is going to be the longest leg, which I know is root 3 over 2, again using the special right triangle of a unit circle. So that means this 60-degree angle, which is also equivalent to pi over 3, would have the coordinates of x comma y, so 1/2 comma root 3 over 2. Okay, so that's just a basic introduction to the unit circle. Once again, for quadrantal angles, you need to know the degrees, radians, and coordinates. And for quadrant 1, the key really is knowing your special right triangles of the unit circle, which we discussed on the back page. And the key to finding these is knowing the rules and that the hypotenuse is 1. Once again, you need to be aware of the degrees, radians, and coordinates. You'll see later how to fill in the rest of the unit circle.